Alright guys, today we are looking at the Pythagorean theorem. Now this is actually something that that we see in algebra that's really more a part of geometry. So the Pythagorean theorem basically allows you to find the third side of any right triangle. Okay, so it's a formula and it can allow you to find the third side of any triangle, of any right triangle. Okay. So now this theorem looks like this. It says a squared plus b squared equals c squared. Now, you guys have no idea what a, b, and c are, so it'd probably be helpful to define what those are. If we have a right triangle, okay, so the triangle has to have a right angle or this doesn't work. There are other formulas that get used that you'll learn about in geometry and trigonometry for how you figure this out if you don't have a right triangle. But if you do, A and B are the two sides that are touching the right angle. The order there doesn't really matter. So it could be A and B, just like that one, or it could be B then A. It doesn't matter. The key is that C has to be the side across from the right angle. Okay, C has to be the side across from the right angle, okay? That side C is called the hypotenuse. Okay, so side C has to be that. A and B are basically interchangeable. And you can kind of tell that that's going to be the case from the formula, right? That A and B are going to be interchangeable because would it really matter if you switched which one A and B was? No, you'd still get you'd be switching around addition. It'd be the same value on that side anyway. So the way you use that triangle, this formula to solve for the third side of a triangle is you would plug in the two sides that you know for either A and B, A and C, B and C, and then you just find the other one. So let's look at how to do that. And the reason we're getting this up here in this chapter is because when we try to solve here, we're going to be needing to use square roots. Okay, so here, what I want you to just think of really quickly is what two sides have I given you? Is that an A and a B, an A and a C, a B and a C? What is it? Okay, so hopefully you figured out that this is A and B. Again, it doesn't really matter which one. So now I'm going to rewrite my formula, but instead of A, I'm going to put 5. Instead of B, I'm going to put 50. Okay, now I can just pull out a calculator and do 5 squared plus 50 squared. And that gets me 2,525 equals c squared. And we already know how to do this, but the way to get rid of a squared is with a square root. Okay, so you don't have to use Pythagorean theorem here. You can just take the square root of both sides. And we get c equals... Now, there's a couple ways that we could write our answer. One way is with a decimal, but the other way is by trying to just simplify the square root of 2,525. Now, I know, because, I don't know, I practiced this a lot, that 225 is a perfect square. Okay? I know that. That's the square root of 15. Or that's 15 squared, excuse me. So 225 times... Oh, no, I'm wrong. 225 doesn't go into it. Well, I may need to use a different method. Let's see. 2,525 definitely divides by 25. There we go. So it's 101 times 25. Okay. And 25 is my perfect square, so I could write this as 5 times the square root of 101. There aren't any perfect squares that go into 101. So we would be done there. Now, you could also write it as a decimal. And I want to get you used to writing this both ways, okay? So if I do 5 times the square root of 101, or just simply take the square root of the number, I get 50.25 if I round to 2 decimal places. Okay, and the reason it's important to also write it as a decimal is so you can make sure that this third side is longer than both of the other sides. Okay, we actually have a limit on the length of that third side. Okay, it has to be, well, you know what? That's something I actually want you to think about. What I want you to think about is, what numbers does that third side have to be between? Okay, what numbers does that hypotenuse have to be between for every right triangle? That's a very good thing to think about. Okay, what I want you guys to do is try using the Pythagorean theorem on both of these other two guys, and I want you to write your answer rounded to 2 decimal places if necessary, and in simplest radical form. So write it in 2 different ways, just like I did in that last one. So do that, pause, and then come back. All right, this one's a little bit different. I've given you C and A this time, so I'm going to write 4 squared plus B squared equals 25. Oops, I already squared the 5. I should write 5 squared first. Okay, so then I get 16 plus B squared equals 25. Subtract 16 from both sides, I get B squared equals 9. And I don't even think I have to write the square root here because I know what number squared is 9. That's 3. So I only have one answer for this one. I only have one answer, just 3, because I don't need to bother rounding or simplest radical forms. It's just a whole number. Did you notice how all 3 of those sides were whole numbers? There are a bunch of different triangles that that have whole numbers on all 3 sides for right triangles. Those are called Pythagorean triples. Okay, so there's a bunch of sets of numbers that always work out to be whole numbers. So if you want to know what the other, so 3, 4, and 5 always work. Okay, so if your hypotenuse is 5 and you know one of the other 2 sides, you can figure out the third. Or if you see the legs are 3 and 4 and you don't know the longest side, the hypotenuse, you'd know it's 5. Those 3 numbers always go well together. So would any multiple of those, like 6, 8, and 10, will work out to be whole numbers in the Pythagorean theorem. If you want to know more about Pythagorean triples, do a quick web search, or you can ask me about it in class too. That's definitely okay. Now the last one, I gave you A and B again. Okay, so I gave you 20 and 20 for A and B. Each of my 20 squareds is going to be 400. So I'm going to get 800 when I add them together. This one should be really pretty easy to use perfect squares method on. I know 400 is a perfect square, and the reason I know that is because I just did 20 squared is 400. So this is going to be 400 times 2. And the square root of 400 is 20. So I get 20 times the square root of 2 equals C. And then I got to make sure that I write this again another way. And the other way to write the square root of 800 as a decimal is 28.28. And again, I want you to make sure you're writing it as a decimal too, or at least figuring out what it is, because again, that third side has some limitations. So the one thing I want you to think about, other than the Pythagorean theorem itself, is what are those limitations on the third side of that right triangle?